Hello, I think it's time. Um, Welcome to the TEAS working group session in IETF 110. My name is Pawan B. Ram, and I will be co-chairing this session along with Lou Berger. Matt Hartley is our working group secretary. You should be able to access the meeting materials for this session using the first link that's specified on this slide. Next slide, please. This is the IETF Notewell. It sets the ground rules for the way we interact at the IETF. If you're not familiar with it, please do get yourself familiarized quickly. You can use the link at the bottom of the slide to get the complete details. Please do note that anything that you say here in session or on the mailing list is part of our public record. Next slide. Uh, with regards to meeting logistics, you're already using Meet Echo, otherwise you wouldn't be here. The integrated chat or Jabber is available for use. We'll be tracking that. If you type in a comment that needs to be repeated at the mic, please do use @mic and we will have it repeated. You don't need any explicit blue sheet signing to be done in these online meetings. We will be using CodeMD for minute taking. A link for that was pasted in the chat. Um, any help with regards to note taking would be greatly appreciated. And while taking notes, do remember that you just need to capture the discussion and not what is being presented. Next slide. This is the agenda for today. As noted in the list earlier, we have a very packed agenda, and this is going to be a good test of the time management skills of the co-chairs. As you can see, we don't have any time scheduled at all for the working group draft updates on the agenda. We sent out a link to a slide deck that has the collated status reports. Please do go through them and use the mailing list to ask questions or send in your comments regarding the status of those documents. As always, we have tried to give preference to the working group drafts and the drafts that have had some discussion time on the list while putting this agenda together. We have about 20 minutes on the agenda today to discuss the IETF network slice definitions, and I believe there's a change in the presenter. Reza would be presenting this now. Next slide. Please do use the mailing list as much as possible. Please be aware that this is where the working group consensus is actually determined. We don't know how long we will continue to be in this online mode, so we'll try and make the best use of the tools that are available to us to make progress on the documents. Working group members can always request for an online interim to be scheduled if there is sufficient interest to cover a specific topic. Also do note that we already have several working group participants making use of the working group WebEx to hold a regular informal working meetings. You can request the chairs if you have such a need. These meetings will be announced on the list and will be open to all. Next slide. As a reminder, we do have an IPR process in place for our working group. There are two mandatory steps before accepting a document into the working group and before taking it to the last call. We do mandate all authors and contributors of the document to explicitly come out and state if they are aware of an IPR that applies to the document. In addition to these two required steps, we are now introducing another step in the process. If any new author or contributor is added to a working group adopted document, we do request them to send out an IPR statement to the list. Next slide. With respect to document status, there were no new RFCs published since the last meeting. There is one in the RFC 8SQ, that's the PC native IP draft. The draft that talks about GMPLS signaling procedures for SMP, that just finished the last call. We expect a new version to be published for that before we can take it to the next step. We did adopt two documents that were produced by the network slicing design team. We would like to acknowledge all the hard work that went into bringing these documents into this particular stage, and we would like to thank everyone involved for their efforts. There is still a fair bit of work to be done before we can proceed towards publication with this work, and we do look forward to more fruitful discussions in the coming weeks and months that will help us get there. Next slide. We do have two young documents that are not being presented today, but they are ready for working group last call as per the authors. These are the young RSVP and young T documents. Please do review them in anticipation of the last call. There is also this pending question regarding the PCCC use cases document. We did pose the same question in the last meeting. We asked if we should progress the document to LC. The authors left it to us, and there was no strong opinion expressed one way or the other regarding this by anyone in the working group. The chairs are leaning towards taking it to LC in the next few weeks. So if you have any opinion on this, yeah, please do state it now. I don't see anybody on the queue, so the chairs will discuss this further and take the necessary steps. I do see Dhruv now. Go ahead, Dhruv.
Hi, Pawan. I would also suggest maybe we should talk to the new AD and see if the new ISG has, the main issue earlier was whether the use case document should be living documents or whether they should be published in RFCs. And maybe before we proceed, it would be good to maybe have a quick discussion with our AD as well. What does the chairs think about that?
Yeah, we will discuss this and take the necessary steps. If there is any opposition going forward on taking to the last call, we will figure that out during the LC process.
Yeah, as someone who's holding the pen, there are a few sections which are empty. So if we proceed to working group LC, just give me a heads up and I will finish up on that as well.
Sounds good. Yeah, thanks.
Thank you.
Next slide. There have been no liaisons or communications received since the last IETF. Next slide. Like Dhruv mentioned, we do have a change in our AD. John Scudder will be officially taking over from Deborah as our AD tomorrow. Lou and I would like to take this opportunity to thank Deborah for all the great work that she has done as an AD, and we would like to wish her the very best with her new role with the IAB. We'd also like to welcome John to the working group. We look forward to working with you, John. So that brings us to the end of this deck. Next up, I believe, is Dhruv.
Okay, hi everyone. I'll quickly go over update of couple of these Yang models. Next slide. A quick overview of what all the model updates that I will be covering. We have a VN Yang model. We have a telemetry model that augments the IETF TE and IETF VN. And then we have a service mapping models, which has a common types and various augmentations to the service models and the network models. So let's go over the update of all these models in quick fashion. Next slide. And maybe you can skip to the next one as well. Yes. So a quick overview. This is the Yang model for VN operation. It is the customer view of VN. It reuses the T topology and T tunnel, as in like VN topology is built over the single node abstract topology model, and it uses the connectivity matrix for description of how the VN connectivity and VN member connectivity is done. So this is our at a very high level, what is the overview of this VN Yang model. So next slide would show what all updates that we have made. We have got the Yang doctor review, so thank you for that. The main comment was the handling of VN compute RPC needed to be described in a better fashion, and we have done that. We have added error handling for the same as well. We got comments that we were redefining a lot of statuses, so we have gone back and used the T common types wherever we could. So those were the comments which we have handled from Andy, and there were some minor comments as well, which we are very thankful for the Yang Dector review. We got comments from Tom Petch as well, which were handled. In the last IETF 109, we got a comment related to VN Compute RPC. There was a pending item there which was describe this via figures. So we have done that. So that should be very easy for anybody to read and understand why this change was made. So these were all the recent changes. We still have some open issues. So that's next slide. In the open issue, the main issue that is pending is naming. Our earlier name is what you see up on the first point, which was AP slash access point list slash access point ID. We shortened it a little bit, made it AP ID, but then slash AP is something that is not preferred. So we were thinking either we go by APS as in apps, or maybe extend access point slash AP slash APID. There is mix of usage of both that we saw in other published documents, and this is something that we have to handle at AP level as well as at the VN level. So if there are some good guidance from folks, please suggest what would be the best naming that we could settle on. We also had a residual impact of one of the changes that we made, which was about reusing T common status. In some places where we are using T common status, some of the enums or some of the values like maintenance do not make sense. So we were thinking that maybe we can just describe that in the Yang text, that these some values are not applicable and they should be considered as unknown as one way forward, or we need to redefine the common status just for the use case inside VN Compute. So these are the two open issues that are pending. So if anybody has any feedback on that, please send us either on email or right now. And then I also have an open discussion point, which is in the next slide. This discussion point is mainly about how do we handle VN when our VN members are realized by SR paths or SR policy. As I was mentioning in my overview, that we reuse T topology and we rely on the connectivity matrix. Uh, 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 Connectivity matrix, but when the original T topology was developed, our thinking was that this could be the underlay could be RSVP paths, or it could be SR policy or SRT paths as well. That doesn't seems to be true anymore. So in this scenario, what is the best way to map VN members to SR policy? And this is not just related to VN, but I would think that this is the bigger question that we should handle with respect to the IETF-TE Yang model. As in, what will be the relationship between these models and the SR policy is not very clear. We have an SR topology, but we are not sure whether that can play any role. In fact, today on agenda, we have T profile. Can that play a role? So I was hoping that we could use this way to trigger some discussion. I can of course take this to the list as well and try to get more feedback on this, but I wanted to know whether these are the right set of questions with respect to discussing the underlay of SR policy with respect to VM. Before I continue, if there is any questions on this, maybe we can spend a few minutes on that and then we can proceed.
Tarek, go ahead.
This is Tariq with Juniper. There is another model, Dhruv, for realizing SR policies. There is a separate model for TE tunnels. Originally, we had thought that tunnels can be SR. You could support tunnel SR paths with tunnels, but then the Spring Working Group decided that the SR policy construct is it's not analogous to a tunnel. Is that what's triggering your question here? The underlay path discussion? Is that my understanding correct?
Yeah, my requirement was that when we started with VN Yang model, we decided that we would reuse T tunnel and T topology as much as we could. But now that has led us to not being able to map to SR policy, and that's a big issue. So if the conclusion is that maybe we need to have some case statement up in Yang model, and whether in some cases we map to T topology, and in some cases we map to SR policy, that the way forward for us to handle this. But that will make things a little ugly, as in currently what we have concluded looks very, very neat, but I'm not sure whether that's the best way forward. But I think worth discussing some more.
Exactly. I agree with you. It's worth discussing within the working group. We had started to model the SR path, which is a color aware tunnel in our T tunnel model, but then we backed out because of the interest in Spring. Maybe we should resurrect the discussion. I agree.
Tariq, when we analyze the SR policy Yang model, the main issue that we see is like it is missing a lot of the constraints information that we currently have in the T tunnel model. So what's happening is that from the VN point of view, or from the northbound interface point of view, it should not really matter whether the underlay is RSVP or underlay is SR. The constraints part should be as similar as possible. So in some ways, I think what Italo did for topology profile, do we need to do something for tunnel profile as well? This is quite confusing. So we need to, as a working group, give a very clear way forward here.
Oscar, can you make that quick?
No, just to add that currently the SR policy model is only a device model, so it augments the IETF routing model. Okay, so it's not applicable for a northbound, and that the problem is similar for the service mapping case. There is another draft of the service mapping to attach tunnels to, or traffic engineering tunnels to services layer 3 or layer 2, and we faced a similar problem there.
Okay. So I think it's clear that the SR policy data model needs to start using some of the T groupings and containers that we have developed in this working group. I think that's an action item on the SR policy Yang document author's point. But for Dhruv, for your model for the ACT and VN Yang, I think there are two things that you probably need to worry about. One is the underlay topology, and then the underlay paths, right? The underlay topology, you can directly reference the SRT topology model that we have defined in this working group. That should work seamlessly. The problem is, I guess, with respect to the underlay paths, the way it's defined in the T topology model is it uses a generic T path construct, and that doesn't necessarily align to this notion of NESA path. But yeah, do take it to the list. This is something that needs to be resolved.
Yeah, thank you. And let me just quickly cover. Based on time, maybe I think let's just directly jump to the service mapping, and I can skip the KPI because the update is very small there. Okay, so this is the service mapping Yang. As was earlier mentioning, it maps the services with the underlay resources, which could be T topology, T tunnel, or VN model. Next slide. So the main change that we did was we got a requirement from Kenichi, which was discussed on the list, whether we should allow the L3 SM and L2 SM site and site network access mapping, which is per QoS profile level to VNAP, VNAP, and this has been done. What is still missing is we need to add a clear description for this use case, and that I'm discussing with Kenichi and will update in the next version. Some other changes that we made was also to allow T mapping templates, which was earlier put inside a choice statement. But since we thought that T mapping template is something that can be lived on and it is independent of the other mapping types, and we have moved it outside of the choice. We added one more generic container for policy requirements so that they can all be grouped together. Next slide. We also added some examples on how the T mapping template could be used. So in the first example, we are basically saying that the requirement is to optimize path metric delay average. In the second requirement, we are basically saying that you have two constraints. One is bandwidth, and another is based on hop metric. Similarly, more examples have been added for ease of understanding of our models. Can we directly go to the last slide then, Lou, since I'm out of time? So we also had some further discussions that were happening related to traffic, that how do we put a particular map traffic to the paths. This is of course not part of the T service mapping, but this is again an open question to the working group, that where should we model this. There are also requirements with respect to calendaring and scheduling T resources, which are currently not modeled, and we are not sure, because the requirements somehow came to us, but we were not sure whether our Yang model is the best way. But we wanted to trigger some discussion on where to model these in future. And that's it. I'm done. Thank you.
Okay. Thanks, Drew. Yi Lin.
Can you hear me clear?
This is not the slide deck. This is.
Give me a second. Give me a second.
Okay. Thank you, Chas. This is Yilin on behalf of the authors list here to present a slide for the interworking of GMPS control and the centralized control system. Next slide, please. This draft is actually about describe how the GMPS control system can interwork with the centralized control system in different scenarios. For example, multi-domain, multi-layer, or recovery scenarios. And the main changes of this 05 version is that we added the description about the LSP recovery in the GMPS and centralized controller system interworking scenario. And next page, please. So this slide shows a brief introduction of the idea of this draft. So we know we have the GMPS control system, and in each domain, and we may also have other domains which are running different protocols than GMPS, and on top of them, we also introduced the ACTN, the centralized control system, such as the ACTN architecture. And the centralized control system and the distributed GMPS control system, they are not competing to each other, but they can work together to make better control of the network. So that's the main idea of this draft. Next slide, please. So what we added in this new version is that we are actually analyzed on how the LSP is recovered in this GMPS and controller interworking scenario. So actually there are three scenarios: the span protection, LSP protection, and LSP restoration. So for span protection, the first one is actually a kind of a link level protection. So we believe there are no new extension needed for in these scenarios. And in the second one, the LSP protection, we think that the centralized controller can help on the disjoint, the centralized way of path computation for the disjoint path computation. And in the switchover stage, we can still use the distributed way to do the protection switchover because it's a much faster reaction in the distributed way. And for the LSP restoration, there are two kinds of methods. One is the pre-planned LSP restoration, and the other one is the full LSP rerouting. So for the pre-planned LSP rerouting, similar to the SP protection, the centralized controller can help on the centralized path computation and considering with the resource sharing on the protecting LSPs because it has the global view of the network. And for the full LSP rerouting, the centralized controller can help on the pre-compute of the rerouting path and store in the controller or in the source node of the LSP. And once the network change, the controller can trigger the refreshment of the pre-computing restoration path to make the better use of the resource. So to sum up, we think that the centralized control system can take the advantage of centralized path computation, and the distributed control plane can help to make a faster reaction to the network event, for example, the switchover, etc. Yeah, that's the main idea. Next page, please. We think we have finished most of the work of this draft, so we kindly ask the expert in the TEAS to help us to review on this draft and feedback to us via, for example, the mailing list, and before we asking for WG last call. So that's all for the slides. Thank you.
Comments? One thing I noticed in reading the document is you don't cover FRR, and that's probably something, fast reroute, you probably want to add that.
Oh, FRR, yeah, yeah, we can consider. I think we can add more tests about FRR in the next version.
Great, thank you.
Thank you.
Reza, you're up next.
Okay, thank you. Can you hear me well?
Yes.
Hello, everyone. My name is Reza Rakui from Nokia. On behalf of my co-authors, Shunsaka, Kiran, Luis, and Jeff, I'm going to present the IETF network slice draft. Next, please. If there is any question, it would be great if you can hold on to your question. We have at the end a QA. Hopefully, as we go through the slides, I will answer the question as well. So the current status of the document, as most of you are aware, this document has been adopted as a working group document beginning of this year. Most notably, the term transfer slice is renamed to IETF network slice. There are lots of good discussion. I encourage you to take a look at the link, which is given here, why we come up with that name. And for last few weeks, there are lots of good discussion on the mailing list about the draft. And these are the area which was discussed. And as I go through the slides, for each of them, I have one slide to describe that. We sent a comprehensive response also to mailing list last week. Again, the link is here. You can take a look at whatever we discussed today. Basically, the detailed description will be in that mailing list. Next, please. The first item and the suggestion from the mailing list was to use term service and consider the IETF network slice as a service. As we outline here, the co-authors do agree with the suggestion, and as a result of that, as we will go through the slides today, we will see that generally the network slice is considered a service which has a few artifacts, endpoint, connection, and SLO, and we will discuss endpoint momentarily. But this is something that we agree with the suggestion and will be included in the next version of the document. Next, please. Next slide, please.
remind the authors that as a working group document, the working group consensus is what dominates, not the author's opinion. And it's the author's, actually the editor's obligation to match what the working group decides, not what the authors decide. So it was probably just a turn of phrase to say the authors agree. You know, it's important that as a working group document, it's that the working group agrees and that you're capturing that. So minor point, but just want to make sure we're all on the same page.
Yeah, sure. So, there was a very good discussion, lots of good discussion about the network slice, endpoints, NSE, and the mailing list opinion was to use terminology that is related to the CPS, the CEP terminology. So as the stated here, we compiled the various suggestions that was given. We have the pros and cons of each one. The yellow item in the middle, there was a suggestion for the AP. We as a co-authors, the suggestion NSAP and NSE and the access circuit and CE. And the idea here is that we do agree with basically the suggestion here that we have to use the CEPE terminology. Having said that, since the quote-unquote endpoint in this case is not really mapped, is not either of those, you know, C or P, but mapped to that one during the realization. So the suggestion that we have is, and we put it on the mailing list, we need everybody's opinion, that we are suggesting to use a term to have that abstraction view between P and CE, something similar to AP or NSAP, which is aligned with the VNAP, and we put the RFC here. I don't know if you wanted to have the question right now or later. Joel, you are in line.
This slide does not reflect or correspond to the discussion we had on the list. I don't know what the chairs think the conclusion of the discussion was, but I can't get from that discussion to your assertion that you need a different term or to this list of terms that you have put on this list. So I think this is simply a mistaken conclusion from the discussion.
So what is the conclusion that you have, Joe?
Okay, I don't know what the working group's conclusion is. I know what my suggestion was, which was that the endpoint of the IETF network slice was the PE, which you have explicitly excluded from your list of choices. And that the other suggestion that I saw was that the endpoint of the IETF network slice service was the CE. That seemed to be a really nice way to distinguish what we were talking about in the various ways, but that's only one alternative. But this table does not summarize the discussion.
Italo, you are on the list as well, that you want to ask questions, please.
Just a comment that AP and VNAP are not exactly the same thing in RFC 8453. So the VNAP is the association of an AP with one VN, because the AP can be used by multiple VNs. And basically the AP represents the point, as you said, where you have it's a resource between a customer and a provider, and you can use this AP for multiple VN. And when you assign the AP to a given VN, then you have the VNAP, and you can have multiple VN starting from the same AP.
Yeah, so, exactly. Because of that reason, we are suggesting NSAP, similar to that you are approved.
Oh, okay, okay. Was not very clear from the slide.
We will see it. Yeah.
Okay, good. Okay.
Yeah.
That will be aligned. Great.
Yeah. If there is any other suggestion that Joel mentioned that is not here, we will take a look at the mailing list, and we will include them here to make sure the completeness of this list that captures everybody's opinion on that one, and we put it on the mailing list for the further suggestion or conclusion on that one. Next slide, please. Some of the discussion that Joel mentioned is captured here as well. Now come back the next step, or the next discussion that we had on the mailing list was related to how we are mapping the network slice during the realization, as the discussion for the IETF network slice is an abstraction connectivity. When it comes to the real network realization part, there are two main category of the use cases, and also as suggested by the few people on the mailing list, we use the figure 2 of the RFC 3985 as a base for our discussion. The two types of the category for the use cases are described here in short, and in the mailing list we have the more detail. For example, for the first case, which the endpoint during the realization mapped to the CE, the prime example of this type of use cases are in the mobility, 4G or 5G, and I put a few two examples here in the backhaul or the mid-haul network. This is a kind of the mapping that will happen. Again, mapping happens when we want to realize it. We know the network and we want to realize it in the network. The second type of the use case, the mapping happened on the PE side. Again, two examples were given here. When we want, for example, these are not the use cases, these are just a few use cases to capture the idea, data center interconnect and the wholesale transfer. In those cases, when the transfer slice will be realized in the network, operator use the PE to realize that. And if we go to the next slide, we have the picture view of these 2-3 slides that is explained here. This is based on that RFC 3985. We included the idea of, for example, on the top picture, there are a network slice number 2, IETF network slicer is number 2. There are some the endpoint or whatever term that we are going to come up as a working group. It maps to PE, which is during the realization of a transfer slice, network slice, and S2 is that realization that happens in the network. And very similar to that one, in the bottom picture, we described whatever is described before in the, in a kind of graphical way, that mapping now it happens to the CE. There are lots of similarity. Obviously, there are lots of differences and subtle differences between those two pictures. So this is capturing the idea of the endpoint and the mapping, so that we believe that these are related to each other, has a relationship with each other, and hopefully this picture captures the idea. If the answer is we can modify that, I really encourage everyone to send out the suggestion that how we can make this picture the reflection of the discussion that we have. We really need the consensus on this one from the mailing list. Any feedback will be appreciated. If we go to the second last slide, there was another discussion about the consumer versus customer. Again, with Luz, when he mentioned something at the beginning, that mailing lists agree that this term can be used, but we agree that this could be either or. We need more consensus on the mailing list to see which one we have to pick, but there are some good summary from Adrian that I included here just for your reference, that when we talk about consumer and customer, some of these words are really overloaded. Depends on who you talk to and from which vantage point you are looking at it. There are no single definition of either or, and this is up to the discussion on the mailing list. We believe that the either term could be potentially a candidate, but again, when there is a consensus, that will be included in the next version of the draft. John, please. John, it seems that you have a question. Okay, I cannot hear him. I don't know if this is the case.
John,
There's an issue.
John, you can ask your question. You can unmute yourself and.
John, you can also type it in Jabber.
Yeah, I guess the question is, when are the chairs going to decide the consensus on terminology?
I think the discussion is still ongoing, and maybe we're getting closer. Ultimately, we like for the editors of the document to make the call, and if they don't, then we'll make the call. But I don't think we have, I think Joel's right. We have not fully closed it on the list.
I'm not sure that's what Joel said.
What I said was that the list that they had captured was not the full list that had been brought forward in the discussion. That's separate from whether there is or is not a rough consensus on what the answer is. That, I think in this situation, the working group chairs need to be watching for and judge when it is achieved.
We're watching, and we think there's still a little more room for discussion. Eric?
Do you need to unmute? Okay.
I did.
Go ahead.
Okay, so unfortunately, echo. So a couple of things. One thing at the very beginning of the presentation, you started with this as the network slice graph. This is actually just definitions graph, mostly about terminology.
Eric, you are breaking up.
It's not a generalized graph. And the other thing is part of the discussion is driven by the need to eventually, I think, merge these graphs. And so we kind of have a consensus on what this graph is going to say. That's it.
Eric, I'm not sure I got everything you said. I think you're saying that there's agreement on that we have a definitions document, we have a framework document, and we have an expectation of them merging. I think you said one additional point in there, but I didn't hear it.
It's funny. I'm hearing myself being echoed from somebody else. So I'm not getting through. The other point that I make is we need to arrive at consensus on terminology as quickly as we can. We can't do any merging until then, unless determine that that's the best way to get consensus. Was that clearer?
Chairs have talked and said, sort of reached the same conclusion, as we'd like to get the terminology solid as quickly as possible, and then move on with the merge.
Right. Thank you.
So this is the last slide from my side. Working with a mailing list and get all the suggestion consensus and include in the next draft. Any other the discussion and comments are also welcome. Thanks.
Any other comments for Reza?
As we move on to the next presentation, I think this is a good point to mention that we have a bunch of documents now that are moving more towards solutions. And we're happy that we now have the definition document close. I know we're not done, and an adopted framework to serve as a foundation for those excuse me, those definition documents, we do think that there's a bunch of good text in those documents that could go to the framework and are going to suggest to those authors to make suggestions on the list to incorporate pieces that they think are missing in the framework and suggest that they bring it into, make specific suggestions on what they would like to see in what is now a working group document. So with that, we're going to go on to, this one's next. Sorry, I'll have to find the right presentation.
Tarek, I believe you're next. Can you?
Oh, okay. All right. These are our slides. Can you hear me? Hello?
Yes, we can. Yeah, we
okay,
can.
Great. Hello, everyone. My name is Tarek, and I'm going to give you an update on this document that's a solution document for realizing network slices in IP and MPLS networks. The update is on the behalf of the co-authors shown on the slide. Next slide, please. Okay, so on my agenda is a quick update, and I'll do a recap of the solution that we're proposing, and then close off with some next steps. Next slide, please. So since last presented in IETF 109, we have added some key terminology to the draft. And we've merged the draft PENG-TEAS network slicing into this one. The co-authors joined this effort. And we've received some very useful feedback from the working group, and we've addressed those comments in the recent revision. Lastly, some new co-authors joined, and we thank the working group for the review comments that were provided. Next slide, please. So some key terminology that was added or clarified. We have the slice policy. It's a construct that is used to support IETF network slices instantiation. The enforcement of the slice policy on network elements creates this slice aggregate. And the slice aggregate is a collection of packets that match a selection criteria and are offered the same forwarding treatment. The slice aggregate may be comprised of one or more IETF network slices or slice traffic streams. The mapping of one or more IETF network slices to a slice aggregate is maintained in the IETF network slice controller. I see people are lining up on the mic. I don't want to be rude, so it's up to the chairs if they want to let people ask their questions, or I can continue. I don't mind either way.
You have 8 minutes to do with run as you see fit.
It's very hard. Throw it on me.
Discussion is good. Discussion is good. You know, people can read the drafts and slides.
Okay. Thank you for making me the choice, take the call. Adrian, please go ahead.
Yeah, thank you. Try to be brief. I'm struggling with the term slice policy because it didn't fit with the meaning that I expected, which was the set of rules that a router might apply to a big pile of packets in order to decide which packets went onto which slice, and that doesn't seem to fit here with the phrase, which I can't quite decipher, the instantiation of mechanisms. I wonder if you could try to clarify that definition of policy for us.
Indeed, definitely. That if you hold off till the next slide or subsequent slides, it will talk about the parts of a slice policy, and part of that slice policy is a rule that says what identifies a packet as belonging to a slice aggregate. And there are other rules in the slice policy. We can talk about them in the subsequent slides. And I'll let you, chime in after we go through the different parts. I do, now that I was given the choice, maybe it's better that we ask the questions after. So I'll progress given the time constraint. So here's an attempt to quickly define the life of an IETF network slice. We have a northbound interface that the customer, the slice customer provides their intent, and the controller will, part of the IETF network slice controller is to create and manage this network slice and aggregate multiples of these IETF slices into one slice aggregate, and then map the slice aggregate or assign it a specific topology and do resource allocations. And the last step is to push this slice policy definition on select network elements in the network. And as we described on the earlier slide, the enforcement of the slice policy on network elements results in the slice aggregate instantiation. How do we place paths within a slice? We can do that on demand and use a suitable path control technique. In fact, we do not advocate a specific one, but we can work with any of the path setup control techniques defined at IETF. Next slide, please. So a recap on the slice policy. It has 4 major parts: a data plane selector. This is what identifies a packet as belonging to a slice aggregate. A set of control plane resource rules. So these are like bandwidth reservations policies that are enforced in the control plane. And there are data plane resources rules that are downloaded in the data plane, like queuing and so on, and drop probability. And lastly is a customized topology for the slice aggregate. It basically defines what resources are part of this slice aggregate, what links and nodes define the membership of this slice aggregate. Now, the dissemination of this slice policy, the slice policy can be defined on a network slice controller and then disseminated into the network using multiple techniques. You can download them using netconf or advertise it in IGP or any or BGP for that purpose. As I mentioned earlier, the path control technologies, multiple flavors can be supported to select a specific path within a network slice. Next slide, please. So the data plane identifier that can be carried in the packet can take multiple forms. One can think of the VPN label. If the VPN labels can be classified and inspected on transit nodes, a range of VPN labels can map to one slice aggregate. Now, we understand this may not be the most favored option, but we are putting it on the slide as an option. The other option is the forwarding label or the transport label can carry context, the slice aggregate context itself, and then a packet arriving with this forwarding label will map to the slice aggregate. Other options that we are looking into is carrying a specific field in the packet. It can be called as a slice identifier or a SLID. There are multiple attempts to realize this or to carry this SLID in different data planes. I did mention multiple drafts here. One of them is proposing carrying the SLID inside the entropy label in MPLS. The other is defining another field, a forwarding action field. Lastly, it could be a multi-field packet selector that determines the slice. 2 minutes. Okay. Next, please. Next slide. Next slide. So the slice resources.
2 minutes including discussion. That was 2 minutes including discussion. So you might want to wrap up so you give a little time for discussion.
So the slice policy resources, I did mention the control plane resources and data plane resources. These are also rules that are downloaded as part of the slice. Next, please. Next slide. The slice topology, I did mention, and I'm reiterating here, it defines the membership of the specific network elements that are part of this slice. And these can help do path placement or slice-aware traffic engineering. There are multiple forms how we can identify a topology for a slice. I did mention a couple of them on this slide. Next slide, please. I'm going to skip talking in detail about the modes. We have identified multiple modes in the draft, so I encourage people to go through the different modes for slicing in the control plane and data plane that we can do with a slice policy. In terms of next steps, we have presented this work in last IETF. We welcome further review from the working group and feedback. And we think that it is stable enough so that we can ask for working group adoption. Thank you.
Shall we take a couple of questions? Let's try to keep it really brief. We do have 4 minutes at the end of our agenda, so we'll end up using a little of that now.
Sure. Okay, Chen Hao, go ahead.
The new terms slice aggregates and slice policy are a little confusing. Is there any difference from the term VTN in VTN Plus framework?
That's a very good question. We've already engaged. Yeah, I mean, on the list as well, there were points made that the VTN resembles some similarities with a slice aggregate. We don't think that a slice aggregate is a topology. So that's one thing that the authors of this draft are keen on, is that it is not a slice aggregate is not a topology. A slice aggregate has a set of links and resources and nodes that are member of the slice aggregate. It also has the other parts that I described. The topology is one part of it. So that's one difference that we disagree, that a VTN is not equal to a slice aggregate.
I think Robin is next.
Hello?
Yes.
Two comments. First, in fact, in our VTN scalability draft, we already indicated the VTN is also can be used to indicate the resource in the data plane for the isolated network slice, while at the same time is associated with the topology attribute. I wish the co-author, the author of this draft, can have more review on our draft. The first one. The second one, I explain concern in the mailing list, because now there's many this draft in the MPR's working group, CXMAN working group, and the TEAS working group propose the similar ID to encapsulate the ID information in the data plane. But now there's use the different name for the ID. Here use the slice ID, and also we see that
towards the end, I didn't get any question.
But we use the
Is there
VTN ID, but some days use slice ID.
Sorry, you're breaking up, Robin, for me, and I don't know if you asked the question.
I think he's bringing up a couple of points. I think he's suggesting that there's some terminology overlap between conceptual overlap, even though the terms are different between your draft and his draft. And I think he's suggesting maybe to figure out how to align them or work together.
Sure.
I think that's what he's saying. I may get it wrong. I have gotten it wrong.
Yeah, sure. Thanks.
Thanks for decoding that. Thank you for decoding that. And yeah, I agree. We need to investigate further alignment in terms of the terminology. Yeah, we will take it a step forward. No problem.
Yeah, we really are over. So we had 3 people in queue. I'd like them to ask if they don't mind taking it to the list. If they really feel that they need to say something on record, you know, like 15 seconds each, please. Jay Zafar, do you think you really have to say it? If not, please do take your comments to the list. I do think that going back to Adrian's comment on policy, you are introducing some new concepts here. Please consider whether or not they belong in the framework or belong in a specific solution document. And with that, we're going to move on. I'm going to assume people just left themselves in queue, even though they don't really want to be there. We're going to go to Luis's slice controller as soon as I find it. So Luis, if you can unmute and bring yourself up, that would be great.
Can you hear me?
Yes, you sound great. I'm going to go on mute also.
Okay, thank you. So, well, I will provide an update of the draft that was already presented during the last IETF. So I cannot see yet the slides. Not sure if it's my fault or...
My computer's being slow. You're good now.
Okay. So I will do that on behalf of all my co-authors. So please, next. So just as a refreshment of what was presented, the idea of this draft was essentially to present or to identify major components within the network slice controller, the IETF network slice controller, and also to understand how the associated data models could apply to these different components, to the structure that we foresee for that. So the structure essentially consists on 2 main components: the network slice mapper, which essentially takes the customer slice request and process it in order to put into the overall context of the IETF network slices being managed by the provider. And then a second component that was the realizer, which essentially process that information and select the technology, the proper technology, and interact with the network controllers below the NSC. So the models that we consider in this draft were the ones being proposed within the framework of the network slice design team. We have as customers view the WD, TEAS, IETF network slice MBA YANG, and as provider view the LIU, TEAS, transport network slice YANG. The models that are below the network slice controller, that would be the ones interacting with the network controllers, are out of scope of this draft. So next, please. So the updates from the previous version, essentially, we mark 2 to-dos to accomplish for the version 01. One of them was to add 2 new sessions as placeholder for elaborating more on the components that we saw before, the mapper and the realizer. We already created these placeholders and added some initial description for them. Also, something that was pending to be resolved for 01 was to add a mention to the complementarity of the 2 models that I mentioned before, the WD and the LIU models, in order to be used as customer view models. The idea behind this would be that the WD model could be used once we request a network slice, which essentially can be described as an abstract set of edge-to-edge links, while the LIU draft essentially would be used to request an abstract topology of virtual nodes and virtual links in case that the customer requires more view on the slice. And also we addressed 2 comments received in IETF110-TEAS-20210309, one from Adrian Farrell about the idea of mapping the type of models, customer service and network to the interfaces. We go through that in this version. And also there was another comment from Boris Kashanov asking if the network controller could be considered or not part of the logical architecture. We decided to keep yet as part of the logical architecture because this is what is been, to make it consistent with the definitions on the framework draft that by now consider the network controller there. So next, please. So next step will be to collect feedback and comments from the working group, to propose the draft as a agreed outcome of the design team if we yet keep working on the design team structure, or otherwise we will move as a contribution for the group, and essentially to prepare a new version and ask for adoption in next meeting if possible. So this is all from my side. So if there are some questions.
Okay, I think, thank you very much. I don't think we really have time for much comments. Doesn't look like anyone's coming. I'll make the same comment I made on the last one. If you see parts of this document that you think are appropriate for the framework document, now that we have a working group document, please feel free to propose sections on the list for inclusion. Not saying that you definitely want to do that, but just consider that.
Okay, thank you.
And we're going to move on. I'm not sure, Bo?
Yes, I'm presenting.
Okay, Reza, go ahead, please.
On behalf of the co-authors, this is the NBI Yang model. It's very related to the discussion that we had, half an hour ago. Go ahead, next slide, please. On the left-hand side, this is the picture that Luis showed you. The network slice controller has an NBI and SPI. The component that we discussed for this discussion, the Yang model, is the NBI. And as a whole, the NBI model contains, when we consider it as a service, the upper layer asks for a service for the creation of IETF network slice. That request contains basically 4 different major components. One is the type of the topology which is needed, the point-to-one, multi-point to multi-point, and so on. A group of policy which identifies the SLO which is required to create that network slice. A group of endpoints which belong, or whatever terminology we come up, we will modify this one obviously. And last but not least, the link between those endpoints, how they basically should be connected together. These are the majority of, there are some other small component in the Yang model, but these are the 4 group of the components that you will see in the next slide. Next slide, please. Some changes that has been done versus the last update. We removed the concept of the connection group because we felt that we want to be aligned with the mailing list, and basically a single end-to-end, a single IETF network slice as a service contains only one or multiple connection with multiple SLO. We believe that the connection group was redundant in that model. To simplify it, we removed that. The discussion about the PE or CE facing realization for the network slice endpoint also is added here with a few pictures and examples, and a sample JSON also included for the clarity of the discussion. Next, please. The modeling as a very whole is captured here. We have an end-to-end network, an IETF network slice should be created either blue or red with various connectivity. One of them is, for example, multi-point to point, another one is a point to point. The whole idea here is if we want to model this one, the important aspect also is the network that is going to be realized, this IETF network slices, not necessarily IP MPLS. We can think of as a general concept, if that network is, for example, other technology, how we can come up with the model which captures not only IP, which obviously this is the main topic that we have to discuss, but is extensible in such a way that we can extend it to the other type of the network, is optics or PON or any other technology that we want to do that one. So these are the main idea that we consider in the modeling to be as generic as possible, captures all the discussion that we have in the draft definition and the framework, and at the same time bring the clarity to make sure that we address all the component which is needed for the modeling of the single IETF network slice. I have only, I think, one more slide to cover. You've seen this picture before. This is not new, but the idea here is the attribute that NBI has, I guess the message of this slide here is the attribute which specifies the northbound interface. Not all of them are mandatory. There are lots of attributes which are optional, and depends on which attribute is given, the role of the network slice controller is to find the best mapping into the network, and depends on the information which is given, that quote unquote best logic inside the controller will decide what is the best way to address and realize it in the network. From that aspect, the attribute that you've seen in the Yang model, lots of them are optional, and if they are given, the controller is going to take advantage of them to find the best realization and best C or P in the network to realize. Next, please. I can skip this one, but the idea here is just a quick the discussion about the service chaining. It is possible to do that one, but I'm encouraging you to take a look at the draft, take a look and put if there is any comment or feedback, please include it in the mailing. We are asking for comments on this. Please take a look, and we are getting closer to adoption when we converge on the terminology. We will include that here, and in the next IETF, hopefully we reach that agreement for other draft, and as a result, we will be very close to have an adoption of this one as well. And that concludes my presentation. Any question, please?
Questions, comments? I think it's clear that we're going to need a document in this space as a working group document. So it's good to see that it's moving closer. And when you're ready, I think you can ask for adoption, and we'll move forward. If there are significant comments, particularly objections, feel free not to wait for the adoption and call and send it to the list.
Sure. Thank you.
Thank you.
No problem.
Okay.
I'll present this. Yeah.
Okay. Please go ahead.
Yeah, this is a Yang data model draft for managing slice policies in IP and MPLS networks. This replaces the slice per hop definition Yang draft that was on the TEAS agenda in IETF 109. The renaming was done to be consistent with the terminology introduced in the best parties and this packet draft that Tarek earlier presented. Again, my name is Pawan Biram, and I'm presenting this on behalf of the folks listed on this slide. Next slide, quickly. Like Tarek mentioned, the slice policy is a policy construct whose enforcement results in the creation of a slice aggregate. Tarek already covered what a slice aggregate is and how a slice policy can be used to instantiate a slice aggregate. So I'll not reiterate all of those mechanics, but I'll just focus the narrative in this deck on the modeling aspects. So depending on how the shared network resources are partitioned, there are three different slice policy modes that can come into play. A is where the partitioning of the shared network resources is achieved in just the data plane. B is where the partitioning can be achieved in just the control plane. And C is where the partitioning can be achieved in both the control and data planes. And in the modes where the partitioning of the shared network resources is achieved in the data plane, the forwarding engine on each participating node is required to identify the traffic belonging to a specific slice aggregate and apply the corresponding per hop behavior. And that's why we call it based on diffser principles, right? So the identification of the slice aggregate and the corresponding forwarding treatment That's dictated by the slice policy, and you will see that captured in the model proposed in this document. In the modes where the partitioning of the shared network resources is achieved in the control plane, the distributed or centralized resource reservation manager is required to manage slice aggregate resource reservation. And the provisions for enabling that are dictated by the slice policy, and you will see that as well captured in this model. And lastly, in all the three modes, you do require the topology associated with the slice aggregate to be specified in some manner. The rules for determining which topological elements cater to the slice aggregate are dictated by the slice policy, and you'll also see that captured in the model. This new renamed version is consistent with the terminology used in the two network slicing design team drafts and the best bar draft that Tarek had earlier presented. We had some great feedback come in for this since the last IETF, and we believe we have incorporated all of that in this version. Next slide. This is the high-level model structure. As you would expect, the top-level container has a list of slice policies. In addition to this, there is a list of PHBs and a list of topology filters that are referenced by the slice policies. It is structured this way to allow multiple slice aggregates to use the same PHB or the same topology. Next slide. This is a list of the PHP entries. Each entry can be referenced by one or more slice policies. It can either carry a reference to a generic PHP profile that is already available on the node, or it can carry a custom PHP profile. This is a bit similar to how the L3 VPN or L3SM model, L3 VPN model rather, has been modeled. Next slide. This is a list of topology filters. Each entry can be referenced by one or more slice policies. Each entry could either reference a predefined topology or specify the rules to construct a customized topology. So for predefined topology, you can either, we have a couple of options here. You can either reference a combination of algo ID and empty ID. If you want to use flex algo topology, that's the way to go. The other option is to reference a set of T topology identifiers. With respect to construct rules for constructing customized topology, we have a set of include any, include all, and exclude filters. Next slide. This is a list of slice policies. There are 4 key elements in a slice policy, and the next few slides will go over what those are. Next slide. First up is the resource reservation container. This carries data nodes that are required for bandwidth engineering, slice aggregate aware bandwidth engineering. Next slide. The slice selectors container carries a set of IP and MPLS data plane field selectors, which are used to identify the packets belonging to a given slice aggregate. Each entry in the list has an index associated with it. The one with the lowest index is the one used by default by all the topological elements that are members of the given slice policy. Typically, you will find only one slice selector of use to be present, but if the other entries are present, they come into play only when there is a need to override the default slice selector. Next slide. This is the PHB leaf is a reference to the PHB that needs to be applied for the given slice aggregate. Unless specified otherwise, this is the PHB to be used by default by all the topological elements of the given slice policy. The penultimate slide. Next slide. This consists of a list of member topologies and is used to determine the topology associated with the slice aggregate. As you can see, you can have multiple topology filters referenced by the same slice policy. In that case, the union of the topology filters will give you the topology associated with the slice aggregate. The topological elements that satisfy the membership criteria also have the ability to optionally override the default PHB or the default slice selector, and that's captured here. Last slide, please. Next slide. We understand that the working group adoption will take due course, and a lot depends on how the framework draft shapes up in the coming weeks. We would like a few terms to be incorporated in the framework. But that said, the authors do believe that the slice policy model is an essential construct to realize the slice aggregate, and we do believe that it's sufficiently baked and ready to progress to the next step whenever it's deemed to do so. In the meantime, we request those of you who haven't checked this model out to go through it, review it, and send in your comments. Questions, comments?
We have one in the queue. Please go ahead.
Hello, Pavan. Can you hear me?
Hi, Robin. Yeah.
Hi. I'm a little confused about the young models because I think that's the young models depending on the implementation of the control plane and the forwarding plane. But until now, there's not the protocol extensions for the control plane and the forwarding plane are not determined. So how we can go with these young models?
I mean, ideally, I would like to start with the data model first and then worry about the extensions, the control plane extensions that you're talking about. If as a working group, we believe that we require this construct called a slice aggregate, and I believe VTN is also being positioned as a slice aggregate, and I would like to think that is a construct that's required, then it's just a question of how we go about realizing or instantiating the slice aggregate, right? And we are positioning the slice policy as a construct to help instantiate the slice aggregate. And once we get some consensus with regards to that, then getting the IGP extensions to do things like slice aggregate aware TE or some extensions to cover flex algo, those are trivial activities in my head. In getting the data model is the key first step before we worry about the IGP extensions. That would be my take.
A quick comment. Why not information model first? Data model too concrete.
Yeah, that's a good way of stalling progress. But yeah, I mean, we have produced multiple data models in this working group without having to produce an information model. But if somebody wants to take a stab at it, yeah, they are welcome to do so.
Into the list, so this topic's out of time. And Shusong, I think you're presenting next.
Hello, I will present this on behalf of Xuesong. Can you hear me?
Yeah, go ahead, Ji.
Okay, this is Jiedong, and I'm going to give a presentation on this 5G end-to-end network slice mapping topic on behalf of all these co-authors. Okay, next slide, please. Okay, in the context of 5G end-to-end network slicing, it is basically composed of three major segments or technical domains. And in this, the term we call IETF network slice is called like a transport network slice. So this, just to show that the transport slice and transport network is a term we used in the end-to-end network slicing context, and they are correspond to the IETF network slice in the network slice definition draft. Okay, here we list all the network slice identifications which may be used in the 5G end-to-end slicing. Some of these terms like the network slice instance and the network slice subnet instance were introduced by 3GPP, and correspondingly for the transport network, we introduced the TNNSSIs for the transport network slice subnet. And for the network slice mapping between the 5G end-to-end slice to the transport network slice, another term called the transport network slice interworking identifier is used to describe this mapping relationship. And it also to represent the data plane encapsulations used for this mapping on the interface for the connection between the transport network and the RAN and the core network. Inside the transport network itself, there may be another identifier. We use the term here, the transport network slice identifier. It represents this concept, which is internally used in the transport network, and it is can be different from the mapping relationship identifier used for in the transport network slice interconnection. Okay, next page. Okay, this page gives an overview of the 5G end-to-end network slice mapping, and in the different planes. For example, the management plane, the control plane, and the data plane. For the management plane, the end-to-end slice management function is responsible for the end-to-end slice creation and to maintain the mapping relationship between the different subdomain slice identifiers in the access, in the transport and the core network. And in the core network, in the control plane, there's SSAI used for the establishment of the 5G network slice between the access network and the core network. Well, the transport network currently is not aware of this kind of signaling context. In the data plane, this is what we need for the transport network slice interworking identifier. It is for to identify the end-to-end slice mapping relationship to the transport network slice. So this is what we will talk about more in the next page. Okay, next page. In this one, for the transport network slice interaction, there are several data plane options which can be used as the identifier of the transport network slice interaction. Here we list some of the options. One typical encapsulation is using the VLAN ID for the network slice mapping from the end-to-end slice to the transport network slice. Well, we also have listed the other options and give some analysis about the options in different layers. For example, the layer 3 options and also some possible options in the upper layers. Okay, next page. Here are what we have updated in this latest version. Basically, we add some add a reference to the northbound interface YANG model, and we clarify the relationship between the slice mapping and the QoS mapping. Basically, they can be seen as independent behaviors. Further is we detail the specification of the TNSII based on some comments. It's just a new concept for to aid the description in this context. Well, it can be instantiated with either existing data plane identifiers like a VLAN ID or some other IDs. It does not have to be a new encapsulation. Well, it can be pre-allocated as a global identifier, or it can also be used as a local identifier. Okay, next page. So the reason we present this work here is we think we notice a lot of interest from operators who have raised concerns about how to realize the end-to-end slice deployment, and the mapping is one important technology used in this to achieve this. So we think the topic really needs more discussion, and we appreciate more comments and contributions from the working group. Also, perhaps we need some further cooperation between the IETF and also the 3GPP on this topic. That's all.
Any questions? Uma, go ahead.
Hi, G. I think there's a lot of interest from this topic. I think one of the ways to do this, the 5G interactions, a lot of 3G community work in the DMM working group. So if you see there is a working group adopted draft, so see the delta, what is the extra things need to be done. Maybe it's a good idea to bring it to the DMM working group, especially for the 5G interactions. So a lot of delegates participate there, so it's a good time to get the feedback.
Yeah, yeah. Actually, we are open to which working group this draft belongs to, and maybe we can ask about the chair's opinion on this.
Hello?
Yeah, maybe we can take that discussion offline about which working group we should have that kind of discussion.
Yeah, let's take that offline.
No, if Luis is not here, I can present on his behalf.
I'm
Oscar?
here, Oscar, but if you wish, you can go on if you wish. No
No,
issues.
go.
Okay. Should I start then?
Yeah, go ahead.
Okay. So let me present this new draft, which is about the instantiation of IETF network slices in service provider networks on behalf of all my co-authors here in the front page. So next, please. So the motivation was essentially to answer or to target the question that you can see at the bottom of the slide. So how to instantiate an IETF network slice, considering the variety of potential SDN implementations that we could face or we could find in service provider networks. For that, we look at the different assets that we have in the work of IETF. So essentially a number of YAM data models that are being developed for the different purposes. So service data models, network models, TE models, including the mapping of services to TE tunnels, ACLs, routing policies, and so on and so far. Also, taking into consideration the outcomes from the design team in terms of the definition and framework documents, so to understand and to see what could be the expected behavior of the network slice controller. And finally, looking for consistency with some other outcomes from IETF, essentially the frameworks that have been defined in RFC 8969 for automating service and network management, and also 453 for the ACTN, the extraction and control of TE networks. So essentially looking at all of them and trying to understand how they could fit or what could make use of all of this for the different deployment scenarios that we could find in service provider networks in SDN. So next, please. So one starting point was also to see what could be essentially the requirements for those slices. So we depart from the work that is being done in draft Contreras-TEAS slice MBI, reporting a number of use cases and a number of attributes that should be expected to be supported by the network slices. Here we took an example of the 5G service, but well, the idea would be to, from all the attributes that are being reported in that other draft, to have a summary of what could be, let's say, the general attributes, not specific per service, but being comprehensive for all the service expected. But just for an example, because this is an ongoing work, so we took some of them, for instance, for the 5G, the availability of the downlink throughput for illustration purposes. So regarding availability, for instance, nowadays we don't have a YAM data model that could support as it is stated in the 5G use case, so that the availability that is mentioned. We could make use of some capabilities on existing YAM data models for requesting tunnels or paths with different resiliency requirements in terms of protection or restoration, for instance. So we could play with that. Going as another example with the throughput, maybe we could leverage on what is being done in the BPM models that essentially try to specify a bandwidth, a given bandwidth between the interface between the slice and the customer, or even going to the TE models for ensuring a certain bandwidth between the PEs for the service. So these are just examples of what is the ongoing work that we are doing. Next slide, please. So once we understand the requirements and the needs, the idea would be how we could play with the different data models in order to realize the service. So we foresee three options by now. So we acknowledge that we need to refine it, but by now we identify three different options. The first option would be to have a hierarchical network controller that has some other network controllers above. And essentially, in this first option, we could consider that the network slice controller is part of this hierarchical network controller. So in this case, for instance, the slice request could come from the draft WD that was presented before, and we could expect in the southbound interface of this hierarchical network controller to make use of the network models, layer 2 or layer 3, for instance. So the idea here would be to trying to map the different attributes and see how we could realize this leveraging on these network models. So now linking with a structure that we saw before as well, proposed for the network controller, we will have a first exercise that will be the mapping of the customer slice request using this other draft, and then finalizing mapping to these network models. So the realization could be the translation to one or more of this network model request, and the network slice controller. Essentially, we need to we need to have a complete view of the network map in order to have a clear mapping of in which parts of the network to apply the configuration, and then realize the slice, including the selection of forwarding policies, routing policies, VPN policies, or and for sure under selecting the underlying transport network for realizing the expected slice from the customer perspective. Next, please. A second implementation option could be something similar to what is being defined in the definitions and framework drafts. So to have a network slice controller that has below a number of network controllers. In this case, maybe we could consider that the slice request comes from the draft view. That would be the outcome from the mapper and enter into the realizer component. So we highlight it here in this way. And again, we would have in the southbound interface from the network slice controller a mapping to a network model, one of the network models, either layer 2 or layer 3. Here again, the idea would be essentially the same for mapping and for realizing. So the need of having the complete view of the network in the network slice controller, and also to realize including forwarding policy, routing policies, and so on and so far. Next, please. And the final option that we do foresee by now would be to have a network controller that incorporates the network slice controller, and essentially we could have on the northbound interface of this network controller a service request, for instance, a layer 2 VPN or layer 3 VPN that is realized by a network slice. So essentially, we have a layer 3 VPN being mapped and being realized in a network slice. So next and final slide, please. So conclusions. There is a wide variety of jam models currently being progressed in IETF. Some of slice requirements could be satisfied by these models, probably some others not. So this is something that is we need to look at that in order to ensure a straightforward realization of what is being requested in the northbound interface. And a more detailed definition for those uncovered requirements is needed. So this is work in progress. Next step from our side is to keep working on detailing the different implementation options. We identified these three, but we need to refine. This is clear. Collect feedback and comments from the working group, and prepare a new version for next IETF. And that's all from my side. Thank you so much.
Yeah. Next presentation. Thanks, Luis. Wang, are you a presenter?
Hello?
Hello.
Yeah,
Hello, everyone.
Yeah, go ahead.
Me?
We can hear you. Yeah, we can. Go ahead.
Yeah, hello, everyone. I came from CMCC, and I'm going to share this topic on behalf of Wei Changchen. Thank you. The topic name is IETF network slice use cases. Next page, please. First, this slice is about the modification. The IETF network slice definition describes a number of use cases benefiting from the network slicing. And also, it clearly states the services that might benefit from the network slice. They include, but not limited to, the above use cases. And this document supplements two cases from the perspective of the operators. So in general, it's a supplement to the IETF network slice definition. Next page, please. This page shows the two use cases in this draft. The first one is the end-to-end slicing cloud network collaboration. And the second one is the branch departments that use slices within the operator. And the detail will be introduced in the next slides. So next slide, please. The first use case, as the picture shows, there are several domains: MAN, Edge Cloud, IP backbone, and DC domains. And they are controlled by their own controllers. All the controllers connected with the higher level operation systems, such as E2E network slice orchestrators. All these domains need to be coordinated in order to deliver a cloud network slice for enterprise. So for example, in this figure, the network operator has created two E2E network slices. So there are two types of traffic from the client, and each traffic is mapped to different slices, which is NS1 and NS2. Each NS with its own MAN, Edge Cloud, IP backbone, and DC network slices. So this mechanism should be used to establish network slices in different domains. That's all for this page. Please, next page. This slide describes the second use case, the branch departments that use slices within the operator. In the first picture, there are multiple sub-company networks, A, B, and N. And there is an IP backbone network. They are all in the same operator IP network. Similar to the first use case, they are also controlled by their own slice controller. And the IP backbone network need to be coordinated with the sub-company in order to control and calculate the end-to-end path. So the information related to the IP backbone are sent to the IP backbone network slice controller. And the next picture shows the detail about the use cases. From this picture, you can see that user rights, network resources, and sub-network resources can be allocated for different users through the role-based rights management. So this is the second use cases in this draft. Next slide, please. This slide appended the resource management, the network slice resource management for the second use cases. So there are slice ID, node ID, SR policy color, VPN name, and the VLAN sub-interfaces. It's just appended. So next slide, please. That's all. That's all for this draft. Any comments will be welcome. Thank you.
Thanks, Wang. Don't see anybody queuing up. We can jump to the next one. Louis, do you have a question for Wang?
Yes, I have a short question, just to reflect the point that in there is another draft, the draft Contreras-TEAS NBI, which is documenting a number of use cases with trying to identify the attributes that I referred before. So probably it would be good to check that and to see if the use cases here reflected are covered by that other draft.
Okay, please take that to the list. G, you're up next. G.
Can you hear me now?
Yes, we can. Yeah, go ahead.
Okay. Hello, everyone. This is Jedong. I'm going to present these scalability considerations for the enhanced VPN on behalf of the co-authors. Next slide, please. Yeah, some background. The VPN Plus framework is described in the enhanced VPN draft, which is adopted 2 years ago in the TEAS working group. It is described as layered architecture and the technologies to provide the VPN Plus services. And one typical use case is the network slices. And then VTN, the term is basically describe a virtual underlay network with a customized topology and also a set of dedicated or shared network resources. As shown in this figure, we can create multiple VTNs based on a shared physical network, and each can be used as a virtual underlay to carry one or a group of VPN Plus services. With the demand for the VPN Plus service increases, scalability becomes more and more important in the solution design and deployment. So this document gives an analysis about the scalability of the VPN Plus service in terms of the control plane, the data plane scalability, mechanisms, and optimizations. Okay, next page. Since the typical use case of a VPN Plus is to deliver the IETF network slices, we think the number of the network slices needed would reflect the requirements on the VPN Plus service. In this figure, we give some possible scenarios of the network slice and the typical numbers expected for each case. We can see for different scenarios, there can be different numbers expected from 10 to 100 and to 1,000 or even more. So for the solution, we need to meet the requirements of different scenarios. From the initial deployment, a solution for a relatively small number of the VPN Plus or VTNs can be used, while a high scalable solution is needed to ensure the massive deployment in the future. Okay, next page. Okay, for the control plane scalability, we list several aspects which can need to be considered, including the number of protocol instances needed and the number of sessions, number of routes advertised, number of attributes associated with each route, also the number of the routing computation, such as the SPF computation executed on the nodes. In addition to the distributed control plane, the centralized controller may also have some concern in this aspect because of the load on the communication channels and the processing burden for the global computation may increase as the number of the VTNs increases. Okay, next page. For the control plane optimization, we proposed several approaches in this document. The first is we can use a shared protocol instance or protocol session for the information distribution of multiple VTNs. As shown in this figure, we can create one IGP instance using one IGP adjacency for the distribution of multiple VTN information. This can avoid the overhead of increased number of the instances and sessions. The second approach is we can decouple the advertisement and processing of different type of attributes of the VTN. For example, the topology attribute and the resource attribute can be distributed and processed. For example, we can create multiple VTNs which can share the same topology so that they can share the computation, SPF computation. This can also reduce overhead in the control plane. For the centralized controller, we can just using the hybrid mode to divide the computational load to the centralized controller and also the distributed control plane. Okay, next page. For the data plane scalability, we think basically we need some identification information to be carried in the data packet so that the nodes can perform the VTN-specific packet processing and forwarding. While the different options of carrying this information can have different scalability implications. The first option is we may choose to reuse existing fields in the data packet to identify a VTN. There are several examples like seeds, addresses, and the existing labels. The pros is we don't need to introduce new fields to the data packet, while the cons is we may change the semantics of the existing fields, the processing behavior may be changed, and the scalability of the existing identifiers may be changed. Another option is we can introduce a dedicated field in the data packet to carry the VTN ID. For example, we can use extension headers or some dedicated MPS labels. This can avoid the impacts to the existing fields, while the cons is there may be some difficulty in introducing a new field in the data plane, especially it need to be processed hop by hop. Okay, next page. So for the data plane optimization, the possible approaches, we can decouple the identifiers used for topology-based forwarding and identifier used for the VTN resource-specific processing. For example, in the IPv6 data plane, we can use the IP address, destination IP address to determine the next hop, and we can use another dedicated VTN ID to identify the set of resources for the packet processing. And then in the MPRS data plane, we can use the top label to determine the next hop, and then a dedicated label or header can be used to identify the resources used for packet processing. The data plane encapsulations has been proposed in drafts in the 6-man and MPRS working group, and there's ongoing discussion about this possible encapsulations. Okay, next page. Here's some history about this draft. The 0.0 version was submitted about 1 year ago. It gives analysis about the control plane, data plane scalabilities, and optimization suggestions. And then the 0.1 version was proposed, submitted last year, November, with mainly editorial changes, and we add a new co-author. The 0.2 version submitted before this IETF, we add some further analysis about the data plane options, especially the pros and cons of each approach. And I also try to align with the definition draft, the slides definition draft about the terminologies. Okay, next page. Here are some conclusions from this analysis draft. First is we think scalability needs to be considered in the design of the control plane, data plane of VPN+. There are mechanisms with different scalability, which may be used for different scenarios. And for the control plane, we can improve the scalability by sharing of the instance, the protocol session, and the computation. For the data plane, we may improve the scalability by introducing the dedicated identifier in the data packet, while the cost need to be understood. There's no advantage without cost. Yeah. Okay, next slide. For the next step, we would like to solicit comments and feedbacks on this analysis and the proposals. And we would like also to coordinate on this extension works in the data plane and the control plane in the relevant working groups. Okay, that's all.
Any questions for G? Don't see anybody queuing up. I guess we have just enough time for the last presentation. Thanks, G.
Thank
you. Italo, you're up. Italo, can you unmute yourself?
The wrong icon. Can you hear me now?
Yes.
Okay, good. Hi, I'm Italo Busi from Huawei. I'm presenting this draft on behalf of co-authors. Next slide, please. What is the motivation? The motivation for this draft is that we have seen a lot of discussions in different IETF working groups, which are discussing similar scenarios where, for example, we have networks which are non-traffic engineering, but for which we need some attributes which are a subset of those which are already defined by the AT topology model in RFC 8795. And there is there was some proposals to create a new models rather than reusing the T-topology model. And the reason is usually the fact that the T-topology model in the RSC looks very complex at the first glance because it's very huge. And the reason why it is very huge is because it is supporting a lot of features, and some of which features are intended to be used only with traffic engineering networks, but other of these features are actually equally applicable to traffic engineering and not traffic engineering networks. And all these features and attributes in the topology model are actually optional. So what appeared very clear to many people outside of the set of people, the authors, is that a subset, something like a profile of this model, can be actually used in specific network scenarios, including use cases which are not traffic engineering. And the draft is intended to clarify this. Next slide, please. And the draft describes 5 examples. These are examples. They are not all. New scenarios may be also useful, may be also applicable, but okay, we focus only on the 5, on these 5, just to show that there are some cases which are non-traffic engineering or may not be traffic engineering, where there are useful attributes in the T-topology model that can be used to address these use cases. Next slide, please. Okay, the next slide you can go quite quick. It's just to show that the profile can be very small. You can see that instead of tens of pages like the T-topology tree, you can stay in one slide because you just need one or few attributes. Next slide, please. I'll try to go. Okay, next. Yeah, also next. Yeah, these are just examples for people to read. Then there was some discussion about how to augment the T-topology model. And there are 3 options. One option is that we can augment the T-topology model or a profile of it, depending on your needs. And this is applicable where you need to provide technology-specific attributes to both entities which are defined in network topology, as well as entities which are defined in the T-topology, like bandwidth or TTPs or connectivity metrics. Next slide. If instead, option 2, what you need is only to provide technology-specific attribute for node links at TPs, you can augment the network topology, and you can still use the generic attributes from the T-topology profile by adopting what is called multiple inheritance. So you can instantiate both a T-topology model or a profile of it and the network technology and the technology-specific network topology model in your network, and that works very fine. And we have also option 3 in the next slide, is where you can split into 2 models, one which augments the network topology and one which augments the T-topology or a profile of it. And there is no big advantage, but it could be a useful option in case where, for example, the network topology augmentation already exists and you want to create add a new attributes for the T-topology. So we discussed these 3 options. Next slide. And we give some example for a link, for example, about where you can put technology-specific augmentation. For the bandwidth, for example, you must follow option 1 or 3. If you want to put something under the T-link attributes, you must follow other option 1 or 3. But if you want to put something under the link, you can do in whichever option you wish or you need. Next slide. Okay, a couple of comments I got offline, which are often issue. The first issue is that since the server implements a profile, how the client can know which profile is implemented. It seems that not an issue when you read the operation data store, because by reading, you know that the server reports only the leaves, the young leaves which has been implemented. Maybe an issue when you write, so you don't know which attribute can be written or cannot be written because not implemented on the server. This seems a more generic issue, and the question is whether we need to discuss it in the draft or somewhere else. And I don't know the answer at this moment in time, and I was planning to send a question to the network working group, but actually I'm a little bit late. Okay, so an investigation with network working group is going to start to understand how to deal or how the client can know whether an optional attribute can be configured or not by the server implementation. And there was also a comment about the option 2 and 3, where we use the multiple inheritance. This multiple inheritance is discussed in many drafts, but not discussed, not detailed anywhere. And there was a question why not using this draft to describe in details how the multiple inheritance can be used. This is a feature of the RFC 8345 and not of the 8795, but I'm open to discussion about whether to do it in this draft or somewhere else. And next slide, maybe we can take the discussion compacted. Okay, the next steps. Okay, we want to advertise this draft. We have already advertised OC campaign Obsidia working group, but if you see any other working groups which maybe benefit from this information, I think we should send this note. We solicited more review and feedbacks. And thanks to Daniele for the first feedbacks, and we can address additional these open issues and any other comments which are received. And the other question is whether there is an interest to further progress this work. And there are some options. One option is to progress this document as an informational RFC. But I know there is some reluctance from the ISG on too many informationals. We may merge the content with a tutorial, or we can do something in a wiki or any other options, just whatever the working group thinks is more appropriate. Thank you.
Okay, I think we are we have just passed our stipulated time. Drew, can you take your question to the list? And Italo, if you can pose these questions on the list, you can probably get some feedback from the working group. Yeah.
Good. I will raise comments on the list. Yeah.
Thanks, everyone. We will see you next time. Have a productive week ahead. Thanks.
Thank you all.